All right, welcome back. In this series, we are still continuing with the Raspberry Pi, and I think we're going to start working on something a little bit different here. Still working with the GPIO, but what I want to do is create a special little server to allow us to communicate with our GPIO lines ultimately from a web application and from other tools and things we're going to use. Now, PigPio has a daemon that we can load up and use via pipes, and we're going to look into that a little bit. But what I've looked at so far is the documentation for using that does not seem to be very good. But we can build our own TCP/IP server fairly simply, and to do that, we're going to introduce something a little bit new. We're going to introduce the Boost libraries. Now, in my previous courses, I've tended to avoid Boost, but Boost has some excellent stuff for both threading and TCP/IP communication and so forth in its async programming libraries. So we're going to download that. I'm going to download this one here, boost1750.tar.gz. Depending on when you're watching this video, this number may be a higher number. It'll probably be okay. Many of the libraries in this do not change very much with these versions. Often this is adding stuff to them or minor changes and tweaks. So, but I will be downloading 1.75, which is the current one right now. If you want to stick with that one, you can usually find these versions. If this is in the future, you're watching this, and you can usually find the older versions on this site, which is the Boost site. So let's go ahead and download that. Well, I've actually already downloaded it, but it only takes a few seconds, and I'm just going to download that URL that was to that tar.gz file, and then what we'll do is I'll show you here basically how to build it. I'm not going to videotape the entire build process. It does take a while, but there's our Boost one. Well, I've got two of them now, so I'm going to rm boost.1. I'll eliminate that, and I'm going to make a directory here in my home directory called libs. You know what? I might already have one. Did I call it lib, or I called it lib? So let's rm libs and cd into lib. I called it. Okay. And what we'll do is we'll go tar minus x f slant down loads slant boost, and we will untar that. I didn't put a V on that, so we're not seeing any output. But it's untarring it. It takes a few seconds to extract this archive file. And hopefully it'll be done pretty soon here. I will pause the video until it gets done. I decided to change it to output what's going on, so you can see here. I just added the V flag to it. It's downloading a lot of stuff. The Boost library is quite large, and yeah, it should be done fairly shortly here, and then we'll start the build process. There's a bit of a configuration process, and then it's got its own kind of build system to pull everything together. Now, one word about that Boost. Many Linux systems come with the Boost header files already installed, because many applications use those. Much of the Boost library is, or at least the most common things used, are header-only libraries. They're just like the standard library. They're template-based systems that don't have any compiled code. You just use the header file. However, the libraries, several of the libraries we're going to use in this require the compiled version. So we're downloading the compiled version. Okay. So we'll change directory here into Boost, and we're going to take a look at a couple of things. Okay, there's this bootstrap.sh, and that's the first thing that we want to run. It's going to generate some files for us. It's going to analyze our system and make sure we have everything that we need to run this. And it's going to build what's called the B2 engine. B2 is a build system. This usually doesn't take too long. It's compiling B2 right now. Usually doesn't take too long to do this part. I will pause the video and come back when this is done. Okay, it's done, and you see here now it tells you the instructions. After you run bootstrap.sh, you run ./b2. To generate the header files, you can run .b2 headers, and then you can get command line help with -- help. And there's a getting started guide and some B2 documentation if you're interested in B2. I have never set up B2 as a build system. I've heard of it, and of course I've used it here with Boost. But we'll first run ./b2, and this one takes a while. Well, it takes a while on my desktop computer. We're running this on a Raspberry Pi, which doesn't have quite as much oomph, though it's pretty good. It seems to be going through. Oh, this is just the configuration process here. It should go through this fairly fast. It's very much like CMake in that regard. It's going to check that it's got everything that it needs, and it'll tell you if it doesn't have something, and if it doesn't, you may have to install some things. But if it finds everything, it should start building, and there it goes. It's building all of the library now. So I'm going to pause the video and come back when this is done building, and then we'll start setting up our CMake list.txt for our project here to take advantage of, or to pull in the Boost libraries that we want. And the nice thing about that is it has its find package system, and you can specify which components of that Boost package you want to pull into your program. So I'll show you how that all works as soon as this gets built, and I'll probably go ahead and install this on the system, or I might just I don't know, I might point it to the home directory here rather than install it on the system. We'll see. It's not difficult to point things at the home directory, so for its libraries. So I'll see you back as soon as this gets done. Okay, so it's built, and here's the path to the include directory for our local library, and here's the path to the linker library paths. So what do we need to do? Well, we need to, well, I'm going to begin by closing this folder. So all we really need to do here is set up a workspace and put a CMake list text in it. We'll do that part now, and then we'll start coding in the next video. Right now, I'm looking at, well, we're 10 minutes in, so so let's go here, create a new folder, and we will call this GPIO server. That's what we're going to create. So, okay. Okay, so we're back. So here's how we set up the CMake lists text. We've got our version number and so forth, the project name, and we're in C++. And what we're going to do is set up Boost so static libs is off, debug libs is off. We don't really need to worry about debugging through the Boost library, so we don't need the debug information. Release libs are on, multi-threading is on, and use static runtime is off. And then here we do find package, Boost 1. Actually, this should be 1.75.0. Let's double check that that's the one I installed. 1.75.0 it is, yeah. And then the components we want, and I just threw some components in here. We're going to grab the date, time, file system, program options. Probably don't really need the unit test framework right now. We might do that. And then we're telling it the paths, and the paths are home, pi, lib, boost 175 /star. And that should allow it to find that and create the include directories. And we'll prove this out shortly, but let's do a CMake. And there we found Boost 1.75.0. And let's just do this instead of this. I don't know why that didn't. Yeah, it did print it out. Boost include DIRs and $, Boost. I believe it would be LIB DIRs. Close that. I'll do CMake ... and found Boost. There's the include dir. Is it link dirs? No, I don't know which. I don't know what variable it is. I'll have to look that up. It doesn't matter. It found it, and the proper things are in place to do that. So we can do something very simple, a simple test. We'll go in here and create a new folder, and we'll call this folder. We'll just call it console, because we'll have an initial console that we'll light things up from to test them out before we make it into a daemon that runs on its own. So we'll create a new file called main.cpp. And so we'll do something very simple. Pound include boost slant. And of course, before we do that, we need to tell change configuration provider, copy to C++, edit configurations, JSON. So we need this path to the include files, which is, where was it? It's here. This is the path to the include files. I'll just copy it. It's be easier, copy. And so here's the include path. We'll put a comma here, quote, put that in there. And now we can close that. When we come back here, pound include, we should be able to go boost slant. We'll do program options. Oh, actually, it's got to be program options.hpp. And we'll go in main. Nope. Int argc return 0. And now we can use the program options. One of the things that we want to do here is go pound using namespace PO equals boost : program options using, excuse me, not pound using, it's just using. Using namespace PO equals. I don't do this very often. Using PO equals using no, it's just namespace PO equals. Oh, come on. Getting slow. PO equals boost colon program options. That should be good. So now we can start setting up program options, and I'll show you how to do that in the next video. Let's do a make real quick on this and make sure this builds. Oh, first of all, we got to do here is go down here. If boost is found, we want to add subdirectory console, and I guess we'll go ahead and make sure that this builds. We'll go into console, add c make lists dot text, and here we'll go add executable. We'll call it server main.cpp, and we'll see, PO colon options description. That'll force it to link something. Make sure the linker's working correctly. Well, first of all, this should have been argc int main int argc character pointer argv. Why is it unused parameter? Linking, we got a linker error. Oh, let me go check something real quick. I think I forgot something. Go here. We'll try this. Don't think that's using it. Test. Oh, that's it. Yeah. So we got to go, I forgot, we got to go to this cmakelist.txt here and go at, target link libraries. $, oh, I've already got it in my buffer, $ boost libraries. That should link everything. Do a make now, but oh, I gotta go server. We gotta give it the target. It's getting a tiny bit slow. Make. And there it is. It linked. Doesn't do anything right now, except it does create that yep, at least it runs, doesn't seg fault or anything. It's finding everything. Those should be using the SO versions of those, I believe, rather than static linking. So we should be good. Anyway, that's it for this video. On the next video, we'll get rolling on our server and start building it using the boost libraries. So thanks for watching. I hope you liked it. If you liked it, hit that like button. If you really liked it, hit that subscribe button, and I'll see you in the next video. Thanks for watching.